Hello YouTube. So we've seen that the causal mechanical model is very appealing in many ways. It solves most of the problems that were posed for the deductive non-logical model, and maybe more importantly, it's probably the most intuitive model of explanation. And obviously I can't speak for everybody, but it does seem to me that causal relations are an important aspect of at least most explanations. It seems plausible that to explain something is to cite the causes. However, this model has received plenty of criticism, and we'll examine some of that in this video. So the first problem is that it seems that the causal model is rather more limited than the deductive nomological model, because causation is only going to be relevant to explanations of events and processes. The deductive nomological model was proposed as a model of the logical structure of all explanations, all answers to why questions. It doesn't seem that the causal model is going to be able to play the same kind of role. Consider laws, like Newton's laws, such as force equals mass times acceleration. We've seen that the deductive nomological model allows us to explain laws. To do this, we use a more general theory, say the theory of relativity, and we show that given this theory, in certain conditions, we can derive Newton's laws, or at least, in the case of Newton and general relativity, we would derive approximations of Newton's laws. This derivation of the laws explains those laws, but force equals mass times acceleration, that's obviously not an event or a process. It's not that something causes this equation, at least not in the sense of causation that was outlined in the last video. It's not that you have one event causally connected to another event, which is force equals mass times acceleration. That's not even coherent, that's just a category error. Another class of explanations that pose trouble for the causal model are what we might call in virtue of explanations. So we might ask, why is this pane of glass fragile? Well, in this case, we cite facts about the molecular constituents of the glass. We say that the glass is fragile in virtue of its molecular structure. Now, this isn't an explanation of an event. Instead, we're explaining why some property obtains by describing a lower level properties or lower level facts that ground the property. This isn't a causal relation where we have one event followed by another event. We might almost say that fragility just is a certain kind of molecular structure. The fragility and the molecular structure are coextensive. This isn't a causal relation, but it's a dependence relation or a supervenience relation. So we say that that B supervenes on A, just in case no two things can differ in their B properties without differing in their A properties. Consider, for example, the image on an LED computer screen. This has certain global properties. There are particular shapes and symmetries and colours and so on. But this picture is produced entirely by thousands of individual pixels emitting either red, blue or green light. Clearly, you would not be able to produce a different global picture without different patterns in the pixels. So we say that the global image supervenes on the patterns of the LED pixels. And clearly this isn't causation. This isn't one event having a mechanical connection to another event. It's sort of the global properties are constituted by the lower level properties. And it seems that the same is the case for fragility. We explain fragility by describing the lower level properties on which it supervenes. And there are numerous cases like this throughout the sciences. Why is salt soluble in water? Well, here we describe the molecular characteristics of salt. Or why does water have such high specific heat capacity? Here we describe the molecular characteristics of water. These kinds of explanations are of very great importance in science, but they don't seem to be covered by the causal mechanical model. A final example is explaining certain linguistic properties. For example, explaining why a particular sentence is grammatical or ungrammatical. Consider this sentence. Rather surprisingly, this is perfectly grammatical, and we can explain this by showing that the use of proper nouns and verbs in the sentence fit certain grammatical rules. So buffalo is the name of a place, buffalo is the name of an animal, and it's also a verb meaning to bully. So here's a sort of translation of the sentence to help you. And if you think about it, you'll see that actually this sentence does make perfect sense. And as a matter of fact, this sentence can actually be extended indefinitely. You can add as many buffaloes as you like, and you still have a grammatical sentence. Again, this is explained in terms of the grammar conventions of English. Notice that this explanation doesn't involve citing any causes. We're instead appealing to underlying rules of syntax. These rules don't cause the sentence to be grammatical. It seems to be, again, a kind of in virtue of explanation. So the causal model is limited to cases where we have one event followed by another event with a sort of mechanical connection between them. Now, I don't know if this is necessarily a problem for the causal model. We might just say, well, look, not all explanations follow the same model. There are different types of explanation in science. If the causal model is correct for explanations of events and processes, well, then that's still a very useful model. It tells us a lot about how scientific explanation works. But this is still quite a significant concession, because one of the virtues of the deductive nomological model is that it can allow explanations in all of these cases. There are laws of supervenience relations, so there are laws that will link certain molecular structures with certain dispositional properties like fragility. Similarly, there are plausibly laws of grammar, or at least rules of grammar in linguistics. So the causal model is much more limited in its domain of application. A second problem concerns exactly which parts of the causal history are explanatorily relevant. Here's an example from Michael Strevens. Suppose that a group of kids are playing with a baseball and they throw it and it smashes a window. Pretty clearly, the baseball is a cause of the shattering and is therefore part of the explanation of the shattering. But the baseball isn't the only causal influence on the window. Another is that the wind will impact the window in certain very subtle ways. Similarly, the shouts of the players will cause the window to vibrate slightly. The wind and the shouts of the players are part of the causal story of the shattered window because they causally influence exactly the way in which it shatters. The precise way that bits of glass are thrown is influenced by the wind and the shouts. Now, since these are part of the causal story, it seems they have to count as part of the explanation of the shattering. But that doesn't look right. That looks wrong. So we might respond to this by appealing to the point raised in the previous video that explanations are always incomplete. Although the shouts would be included in a complete explanation, there's nothing wrong with leaving them out. Whenever we give explanations, we tend to cite only the most important causes. Well, fair enough, but I think that response kind of misses the point here. The point here isn't that it's acceptable to leave the shouts out of the explanation. The point is that it's not acceptable to put them in the explanation. The shouts and the wind shouldn't be cited even as part of the complete explanation. When somebody asks, why did the window shatter? You're not giving them more information by saying, well, a baseball was thrown at it and the wind was blowing on it and the players were shouting. In fact, that would actually be misleading in terms of what causes the window to shatter. So Strevens answers this by suggesting that we can talk about events at different degrees of abstraction. At a high degree of abstraction, there is the event of the shattering. And so this is just the event that the window shatters, regardless of precisely how it shatters. Even if the wind had been blowing differently, the window would still have shattered, just with slightly different details. Then there is the less abstract event, the window shattering with the precise details of the shattering. This event is the exact way the window shattered. Had just one shard of glass gone in a different direction, this event would not have occurred. When we ask for an explanation of why the window shattered, we're asking for the causes of the more abstract event. The specific details of the shattering aren't important, so the wind and the shouts are not counted among the causes, which means they're not part of the explanation. Notice that this approach has the consequence that we seem to have two different events here. There's the less abstract event, which has causes that are not causes of the more abstract event. So the less abstract event, for instance, is caused by the blowing of the wind, but the more abstract event is not caused by this. We might worry that this is metaphysically inflationary. It seems that we're saying that there can be many different types of events, all with different sets of causes, yet these events are coextensive in space and time. So there's the window shattering in the abstract, there's just the shattering, and then there's the window shattering in the precise way that it did, and these are two different events. Now we might want to say, well, it's not that there's two different events here, it's just different ways of describing one and the same event, or we have different ways of relating one and the same event to other events. But the crucial point is that the more abstract event has different causes to the less abstract event, and that raises a question of, well, how can one and the same event have different causes? Causation is supposed to be an objective feature of the world. It's not simply a matter of how we describe the world. So that seems to be a bit of an issue with this way of dealing with it. One way to answer this is to sort of frame it in counterfactual terms. Recall that even Hempel appealed to counterfactuals in explicating the notion of laws, so this seems fairly innocuous. Anyway, the thought here is, well, there's just one event, but there are different counterfactual claims that we would make about it. If the shouting had not happened, the window would still have shattered. However, if the shouting had not happened, the window wouldn't have shattered exactly in the way that it did. Described more abstractly, the event does not counterfactually depend on the shouting. Described in more detail, the event does counterfactually depend on the shouting. So the claim would then be that explanation requires more than just causal connections in Salmon's sense. It also requires counterfactual dependence. This proposal runs into certain difficulties. So we explain why John has paresis by saying that he has untreated syphilis, and under normal circumstances, the counterfactual dependence holds, right? Because if John had not contracted syphilis, he would not have developed paresis. But suppose that John also has some other disease X, which also causes paresis. So he would have developed paresis anyway, even without the syphilis. Given that he has both diseases, his paresis is not counterfactually dependent on either syphilis or X alone. It's not true that if he hadn't contracted syphilis, he wouldn't have developed paresis. So it seems like what we have to say is, well, if John had not contracted either syphilis or X, then he would not have developed paresis. So if explanation requires a kind of counterfactual dependence between the explanandum and the explanans, then it seems that there are limits to partial explanation. In this case of the syphilis of John's syphilis and paresis, we have to cite both causes of the paresis. Citing only one of the causes would fail to explain because the counterfactual would be false. So that may be a bit of a difficulty with this kind of approach. All right then, another problem is posed by prevention of events or events that don't happen. We might ask, why doesn't any muon go faster than light? We find all these muons getting very close to light speed, but none of them ever exceed it. Why not? Well, of course, the answer is that nothing can accelerate faster than light. As you accelerate, you gain mass, and greater mass requires more energy to accelerate further. So as the velocity increases, you need to use increasing amounts of energy to make ever smaller differences to the object's speed. Accelerating to light speed would require an infinite amount of energy. Obviously, that's not available to any muon. Now, this appears to be an explanation, but we're not citing any causes of events. Rather, we're showing why certain things can't happen. David Lewis suggests that actually this is a causal explanation in that it tells us where the causal histories cannot go. We describe the fact we describe facts that rule out any causal story involving superluminal velocities. So in Lewis's view, not every causal explanation needs to cite a cause. It can be enough to describe the boundaries of a system. No causal pathway can cross beyond those boundaries. The speed of light is such a boundary. No matter how much energy you put into a system, you'll never accelerate it beyond that. That's still a causal explanation because it describes the boundaries of causal histories. So that maybe resolves this particular case, but there are similar cases where we don't have strict boundaries. So neutrinos interact very weakly with matter. It's said that the average neutrino could pass undisturbed through a piece of lead a light year thick. So let's say we detect a neutrino that has passed straight through the Earth and we want to explain why this is. Well, surely there is no causal interaction here. In fact, that's precisely the explanandum in this case. We have two causal processes, the neutrino and the Earth, and we want to explain why they didn't interact. But at the same time, it's not impossible for them to interact. Sometimes neutrinos do interact with matter. So again, it looks like in this case we're not going to cite any causes in the explanation, but we're also not going to be describing boundaries exactly. Instead, we just cite properties of the neutrino that make it interact only very rarely. Okay, a final problem. This is raised by James Woodward. He suggests that something that's left out of Salmon's account of explanation is that in explaining X, we sometimes need to cite how certain possible but non-actual histories would have led to X. A good example here are explanations that appeal to what are called evolutionary stable strategies. A simple example is the hawk-dove case. Suppose a population of organisms has two different behaviours. There are hawks, who will aggressively fight over any resources, and they don't stop until they're either injured or their opponent backs down. Then there are doves, who immediately back down in the face of aggressive behaviour. And we can see that each strategy has its costs and benefits. Hawks will tend to acquire and maintain resources, but they will also face injury, possibly death, which the doves will avoid. An evolutionary stable strategy refers to a case where a population adopts a strategy and this strategy can't be invaded by another strategy. Consider a population that all adopt the dove strategy. So they always back down, they never fight for their own resources, so every organism will end up having to share its resources with any other member of the species that comes along. Now imagine that a mutation occurs and a hawk is born. Well, the hawk will fight to keep its resources and it will fight to steal other resources. And pretty clearly, this hawk will never be harmed because its opponents will always back down, so it will acquire more resources. So it will be far more likely to survive and reproduce. The hawk behaviour will spread throughout the population. And that's going to be the case in any population of doves. So we say that dove is not an evolutionary stable strategy. A population of doves can always be invaded by a hawk. Now, in most cases, the stable strategy here will be some sort of mixed strategy. There'll be some ratio of hawks to doves, or maybe the same organism might use a different strategy in different contexts. I mean, this obviously is a bit of a simplification. Generally speaking, you don't get clear, like all organisms being hawks or organisms just being doves or whatever. But this is just a simple example. The point is that very often when we want to explain patterns of behaviour in a population of organisms, we can provide an explanation by showing that this pattern of behaviour is an evolutionary stable strategy. We show that the population exhibits a behaviour that's such that no mutation can arise that will do better and so swamp it. And how does this kind of explanation work? Well, we need to show for different initial conditions how they would lead to the same equilibrium. So we kind of imagine, right, if in circumstances X there had been a population entirely of doves, this would have led to a certain hawk-dove ratio. If in circumstances X there had been a population entirely composed of hawks, this would also have led to a certain hawk-dove ratio, and so on. The point is that this explanation appeals to merely possible states of affairs, and merely possible states of affairs can't cause anything. Recall from the last video how Salmon defended the causal approach by appealing to a Laplacian demon with perfect knowledge of everything that will happen, but that lacks knowledge of the causal relations between events. We might similarly imagine Salmon's demon. This has perfect knowledge of every event that will happen, perfect knowledge of the causal relations between events. Well, Woodward's argument suggests that this isn't enough. To understand the case of an evolutionary stable strategy, to understand those explanations, you need to know more than just the actual causal relations. You also need to know these hypothetical, these possible states of affairs and how things would have developed under those states of affairs. So those were some difficulties facing the causal model. I hope that was helpful. Goodbye.